Morning, everyone. So far we've been looking in this chapter at a bunch of alkanes, single-bonded carbon families. We started subbing on different groups. Alkyl groups are carbon chains. We subbed on some halogen groups here. We're just going to start off with a quick little warm-up here, just to get a little bit of practice, make sure we're all on the same page. Let's try doing it both ways. So let me just sketch a few different carbon bits here for you. Sometimes they try to scare you by putting hydrogens on there, but we see that the name actually comes from just the carbon bits of it. Let me sub on a few different chains here. So let's sub on a F there. Let's sub on a C2H5, and let's sub on a Cl over here. Okay. Also give you a different, just going the other way here. Let's do a 2-butyl 5 iodo heptane. Okay. So two different molecules. Okay. Whenever you're given a structure like that, see if you can write the word name for it. Given a word name like that, let's see what the structure is going to be. Okay. Encourage you just to pause the video so you can just get a sense to try it out. Then you can just check your work with me. Okay. Assuming you've done that here, so let's just try it out. Okay. Again, I mentioned here, sometimes they try to add hydrogens just to scare you away here. First step is always, let's find the longest carbon chain from any side to any side. So I can start from this side, I can start from this side, I can start from this side as well. Just be careful. Chlorine, even though it starts off with C, this is not carbon. This is just a halogen substitution on a carbon chain. Now this is another one of those examples. Wait, we could have actually done two different carbon chains. Even though they condense this on us here, C2H5, that does mean 2 carbons in a row and then 4 carbons like that. That is 6 carbons going this way. It also is 6 carbons going down this way. Okay. I'm going to prefer to count it this way. Okay. So it was 6 carbons going both ways. Technically, it shouldn't matter. The reason why I'm going to prefer counting it this way is I can treat this C2H5 as a branch. That's branched directly off the parent. The chlorine is branched directly off the parent. What if I counted it the other way? Nothing's stopping you from doing it because it is also the longest chain. It's also 6 carbons. But this one, similarly before, well, it's a little bit more complicated because it's sort of like we have a branch on a branch. In this case here, I would have that same 2 carbon branch, but here it's not just a pure alkyl group. This branch here also has an extra chlorine branch. It's a branch off of another branch off of the trunk. That's just a little bit too complex. Now, there is a way of doing that there, but given a choice, again, I choose to, let's make things simple if we can. So I strung together the longest number of carbons at 6. So the very last word in name is going to be hexane. Okay. Hexane would have been 6 carbons in a row. Everything else is swapped on with hydrogen. There's a few places that I subbed on a different group. We have a chloro branch, a fluoro branch. This C2H5, like I drawn out there, it's a 2 carbon branch. It's understood there as carbons. They're holding on to extra hydrogens. This is going to be a 2 carbon branch. Prefix for 2 is eth. So eth. We have chloro, just looking at my alphabetizing here. Chloro is going to come first, then ethyl, then fluoro. And then we just want to make sure we're numbering our parents so the numbers are as tiny as we can get them. So let's just try it out here. We're going to have carbon 1, 2, 3, 4, 5, 6. If I count it off in that fashion there, our branches are occurring at position 1, 3, and 5. What if I counted it the other way, counting it going right to left, I have position 2, 4, and 6. Well, this way of counting has it tinier. So with that, you should be able to finish off the name here. Again, the chloro part comes first, so 1-chloro. Numbers and letters are always separated by hyphens. 1-chloro at position 3, there is a ethyl group. At position 5, there's a fluoro group. And again, if you like, you can just ram this fluoro name directly into the hexane or with the hyphen, that's perfectly fine. Here's an example where the numbers also, hey, they're a nice order, but we've seen previous examples here. Based on your alphabetizing here, sometimes the numbers don't work as nicely. All right. Okay, looking at the second one here, again, different molecule. Your practice worksheet here will actually ask you, okay, can you draw the structure? And they may even ask you, what's wrong with this name? Okay, well, turns out based on our IUPAC naming here, we can draw it no problem. I usually draw it from the ending first. So looking at the heptane, let's just sketch it really easily here, left to right. Let's even count it left to right so that I have no sort of kinking and twisting or anything like that on you there. So I have 7 carbons in a row. Well, what's wrong with this name? A butyl, now we haven't seen this before. But stands for 4 carbons. The YL tells you it's a carbon branch. At position 2, I'm supposed to have a 4 carbon branch, fine. And at position 5, I'm supposed to have an iodine branch, also fine. Okay. Well, what's wrong with this name? Okay. Isn't this a 7 carbon chain with 2 substituents? Okay. What if I asked you this differently? What if I gave you this picture and asked you to name it first? Would you end up with this same name as before? Okay. Well, let's try it out. Our first step is to find the longest carbon chain. Certainly they did this as the longest carbon chain, but it turns out, sure, nothing wrong with this butyl group here. This butyl is a carbon chain. They didn't put it at position number 1 because that would just lengthen the parent. But if I actually count the parent here, what if I started this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 carbons is actually longer than a 7 carbon chain. So in that case there, we shouldn't actually be a 7 carbon chain with the butyl group. We should actually be a 10 carbon parent that happens to have these alkyl groups on the side. So again, really important for you, make sure you have the correct parent, and then we can do the branches on the side there. Okay. So what's wrong with that name there? They didn't find the longest parent. Our longest parent actually has 10. I should actually be counting this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. Okay. So at position 3 and position 6, we happen just to have an iodo group and happen just to have a methyl group. So here we go. Methyl M, iodo is I. So we're going to go 3 hyphen iodo. And then we're going to have at position number 6, 6 hyphen methyl. And we're actually going to be a 10 carbon parent, so methyl decane. Okay. So again, in your worksheet here, they're going to ask you, well, what's wrong with this name here? Well, they didn't find the longest parent. Okay, so moving on. In today's lesson, we're going to be introducing our first type of isomer in this chapter. We'll call this one here a structural isomer. So sort of some of the variety that we can start seeing in this organic chemistry chapter. You'll notice this word here, isomer, actually starts off with the prefix here, iso. Iso means something is the same. So if you think back here, we had the words isotope before, right? The same element, but different number of neutrons. In physics, you sometimes see isotonic, isobaric. Iso implies something is similar. In our case here, to be structural isomers, we actually have things that have the exact same molecular formula. But what's different about them is they have something different about their, well, sure, you can say arrangement, or their different structure. They're bonded differently. They're attached together differently. So let's just see how this works out here. Earlier in our lesson here, we had started off with butane. Remember a couple of days ago, we had called this N-butane when this was 4 carbons in one long chain like that. So far, no substitutions, so you can imagine that the rest of them are just saturated full with hydrogens there. Butane has a molecular formula C4H10. You can try that 2N plus 2 as a general formula just to compare that. We compare that against, if I took this as a methyl group here, imagine this one here actually branched off position 2 instead. I'm going to have 3 carbons in a row and my methyl group here branched off the top. If you count up the number of bonds, you actually realize we actually do have the very same number of hydrogens as before. This also is C4H10. Now for starters, we're going to say, wait a second, how can they both be C4H10? They're different molecules. Again, here's the genius of the IUPAC naming scheme here. When I name this one here on the right, even though I have exactly the same number of 4 carbons, I can't string together 4 carbons in a row. At best, I can only be 3 carbons in this chain. So this is actually going to be a propane, which actually has a 1 carbon branch off of it. Turns out, as we look at these a little bit more, if they are actually different molecules, based on our way of naming them, they should actually have a different name. The one on the left was called butane. The one on the right for all intents and purposes, even though they coincidentally have the same formula, it's actually a different name. So it's a different molecule, slightly different boiling points and melting points, London forces, things like that. They are different molecules that happen just to share the same molecular formula. Which is why when we saw molecular formula, it was good in finding molar mass. It was good in trying to get a sense of like how heavy this compound is supposed to be. But as this molecule here starts getting larger, we find that we have more and more different ways of actually attaching together. Right? So let's just start looking at some of these structural isomers here. Sort of maybe the meanest way of asking this is they can ask you, well, what are all the possible isomers? They want you to choose all the ways I can show this molecule. Okay, let's start off with a slightly bigger one here. Let's say draw all the structural isomers for hexing. Okay. Again, we need to be comfortable going both ways here. Hex stands for 6 carbons. The A and E still reminds me I'm in a single bonded family here. So we're C6. Again, I can use my general formula 2n plus 2. I double the number 6, which is 12. Every carbon should have at least 2 hydrogens, but the 2 more on the ends. So we should be C6H14 right away. Okay. To make sure that we don't skip any isomers, I do encourage you here, let's start off with just plain old N-hexane. Let's start off with a straight chain as long as I can get it. Okay. And then we're going to start slowly shortening the chain, slowly start converting some of them to alkyl branches and seeing where we can actually sub on this branch here. So best way to do this here is just to draw a bunch of these here. So I'm going to draw 6 carbons in a row. That's going to be N-hexane. Okay. You do want to keep track of the name on the side. If you end up having 2 things that are named the same, maybe they might look different, but they actually are identical molecules. Okay. So that's hexane. That's the only way of drawing 6 carbons in a row that way. Okay. And then very systematically here, let's just shorten the chain just by 1 at a time. Okay. So I'm going to shorten. Let's chop off this 1 carbon. Now that carbon here did, for the time being here, had a bunch of hydrogens there. That's alkyl group here. Where could I put this alkyl group onto a 5 carbon chain instead? We've tried previously here. If I have 5 carbons in a row, if I try to sub on an alkyl group either on this side, that's going to be a 6 carbon chain. That's just hexane, same molecule. Or if I try to sub down on the far side here, that's also 6 carbons here, also no different. So the rule for this alkyl group here, it can't be on the side of the molecule. I could put it 1 carbon in though. Let's just verify we're the same molecular formula. So every carbon here should have the equivalent of 4 unpaired electrons. So you should be able to spot all the other spots that have hydrogens there. You add up all of those. Yep, we actually have all 14 hydrogens still there. Everything's so saturated, and yet the IUPAC name is different. So this is a structural isomer. This is now different. We actually have now a pentane, which is a 5 carbon chain. Position 2, there's a methyl. So 2-methyl pentane. Right? Is there another possibility for where this methyl group would go? Okay. Well, we had sort of limited, well, the methyl group here can't be on the ends. What if I put this group here? What if I put it in the middle instead? So let's try drawing it. Let's see if it has a different name. I know the name didn't change by very much. Okay. But if I have that, okay, well, the name is different. So name is different means it's a different molecule. So 3-methyl pentane. All right. Is it possible that I could put this carbon here on the 4th one? Could I get 4-methyl pentane? Well, I could try drawing it. So let's go 5 carbons in a row. And then I'm going to try subbing on this carbon here on the end. Okay. Sure, if I'm counting left to right here, that would be 4-methyl pentane. But remember, our rules for counting is we always want to keep the numbers as tiny as possible. So in this case here, we actually want to count it right to left. Counting it right to left, this would actually be at position 2 only. So that would actually be 2-methyl pentane. This molecule is just the earlier molecule, but looked at from the opposite side. Okay, so this is the same name, so this is not a new isomer. So far, seems like that's all the possibilities I can get. Okay, let's systematically chop it down a little bit more. So far, we had 6 carbons. We chopped it down by 1. Let's imagine taking this and chop it down, either having an ethyl group or either having 2 methyl groups, but all branched off of 4 carbons instead. You'll notice we're doing this really systematically here, just so that I can get a sense of making sure I get all the structural isomers, I don't accidentally miss any. This time I have two methyl groups. Again, methyl is a carbon branch. I'm not allowed to sub on the methyl branches on the sides, okay, or else it would just lengthen the chain. I could put the methyl branch here on position 2, the other methyl branch here, okay. So you should be able to name these for me here. This is going to be 2, 2 dimethyl butane. Okay, so at position 2, there's 2 methyls somewhere on a 4-carbon chain. Okay, you can sort of extend this for me here. You can go 4 carbons in a row. What if we had the carbon on position 2 and the carbon on position 3? Okay, well, that would be 2, 3 with the same ending there. Okay, could I have a 3, 3? Well, let's try it out here. So 4 carbons in a row. What if I had position 3? No, wait, if I counted this right to left, position 1, 2, 3, 4, the smallest position would be at 2. This is actually the very same as 2, 2. So this is the same as earlier. You'll be able to tell whether you have the same structural isomer or a different one if they happen to have the same name or not. Now, in this case here, I had actually subbed them on as 2 different methyl groups. The other possibility was my branch itself may actually be an ethyl group. It may be actually just 2 carbons in a row. So let's just try that there. So we're going to have 1, 2, 3, 4. Okay. We're going to sub on an ethyl group here. Again, as a carbon branch, you're not allowed to sub it on at the beginning, C2H5 like that, or else that's just a 6-carbon chain, that's just hexane. At best, you can draw 2 carbons somewhere in. Okay. So is that really a 2-ethyl butane? Well, had I given you this picture here, when you find the longest carbon chain, you actually just find this carbon chain as your parent. So this is actually a 5-carbon chain. It's a pentane with a methyl group at position 3. Did I have 3-methylpentane before? Oh yeah, I had it before. So same name as earlier. This is not a new isomer. Even if I try to put it on position 3, what it looks like, well, that's still going to be a pentane with a methyl on the side. So the trick is going to be really use the name to actually distinguish the fact whether I have something new or not. Okay. I think that's all the isomers, but we can just continue the process. We went from 6 carbons to 5, put the methyl group in different positions. We went to 4. We tried subbing on 2 methyl groups. We tried subbing on an ethyl group and whatnot. We can just try 3. Now, the reason why I'm sort of thinking we probably hit all of them, as this carbon chain here gets really, really short, that sort of limits the ability for you to put any carbon chains. I can't put it on either position 1 or position 3, or else the chain would just lengthen. That only leaves me the possibility of putting it on position 2. If I put 3 carbons in a row like that, that would already be a 4-carbon chain. If we can, I don't know, let's try maybe something like that. Okay, I'm really sort of out of options here. Well, even in that case there, although it looks like a 3-carbon chain, methyl and an ethyl branch here, if you followed your naming rules, no, the longest carbon chain here would still be this 4. It would still be a butane. And being a butane here, this is a 2,2-dimethylbutane. I think we had that from earlier here, 2,2-dimethylbutane. All right. So again, as you're drawing structural isomers, I really encourage you, as you did in this example here, start off with the longest chain first. Okay. Slowly chop this end off one by one, and then glue it back on in multiple different places. Try sketching the IUPAC name. If you end up drawing a completely different diagram, but it happens to have the same name as something earlier, you've actually drawn just a slightly different twisted version of the one that you just saw. Right? So, all right, we'll do one last example here. So far, we've just been playing around with alkyl branches, methyl branches, ethyl branches, things like that. What if the question here said, draw all the structural isomers, okay? Draw all the possibilities, and they're just going to give you, let's say, C5H11, and let's just sub on a fluorine group. Okay, so another possibility for a halide here. Okay, you'll notice halogens here sort of behave like hydrogens, right? Instead of being, let's say, 5 carbons surrounded everything with hydrogen here, I could have removed the hydrogen by reaction, and I could have glued on another halogen group here. This is actually going to be a fluorine group. We're going to do this really systematically here. Even though they didn't ask me to name it, the name is going to be the best way for me to actually try to find whether I have the same isomer or not. Let's always start off with the longest one first. So 5 carbons in a row. I'm not going to bother drawing the hydrogens in because I'm going to understand that the rest of them have hydrogens. Hydrogens aren't a new substituent or anything like that. In this substitute alkane here, there's only one spot that I've actually subbed on a fluorine group instead. So for this 5 carbon chain of pentane, where are all the possibilities I can sub on this fluorine? Well, again, let's do this really systematically if we can here. Let's put the fluorine on the first. So what's the name of this one here? It's going to be 1-fluoropentane. On a 5 carbon chain, we have a fluorine group that's at position number 1. Because this is not a carbon branch, it could be on position 1 on the ends, no problem. What are the other possibilities for this here? I could move this fluorine. Again, it doesn't happen normally, okay? But I can move this fluorine group down. I can have 2-fluoropentane. I can have 3-fluoropentane. Those have different names, so those would be 3 different structural isomers already. When I try to do 4-fluoropentane, well, now the one and only branch that I had is on this side here. I would actually count it right to left instead. That would be back to 2. This is actually not a new position as we had from previous. So the only possibility of subbing on this fluorine here is on position 1, 2, or 3. I know they're not different by much, but hey, they have different IUPAC names, so that they're going to be different structural isomers. Then again, systematically what we can do, we can slowly shorten the parent chain. It's not going to be 5 carbons in a chain anymore. Let's do maybe just 4 carbons in a chain. Okay. Now I have still the fluorine branch that could be anywhere, but now I've also chopped off an alkyl group. I now have a alkyl and I have a fluorine branch that can occur any place. The methyl branch is a little bit limited. Okay. The methyl branch here, it can't be on position 1 or else that's going to be a pentane. Can't be on position 4 or else again it's going to be a pentane here. Let's just sub on the carbon group here at position number 2. In fact, even if I try putting it on position number 3, I would probably count it right to left, depending on where the fluorine is. So, methyl branch, I'm a little bit more restricted, but at least for the fluorine branch here, I still have all the options here. It doesn't matter top or bottom, single bonds, as we're going to see, can rotate, they can twist, no problem. Okay, so we're just going to name this here. We're a 4-carbon parent, we're now a butane. I'm going to count it left to right because position 1 and 2 are smaller numbers than what would have been 3 and 4. And then just naming the alphabetizing F for fluorine comes before methyl. So this is now going to be 1-fluoro, 2-methyl, and this is off of butane. Okay. What are all the other possibilities here? Because fluorine has the variety, let's try moving the fluorine along. Okay. So if I move this fluorine over to the left, over to the right, okay, it could be on position 2. Well, that's a new one. 2-fluoro, and the rest of it's the same. Okay, 2-fluoro, 2-methyl. I can move it to the right one. Okay, then I have possibly 3-fluoro, 2-methyl, or 2-fluoro, 3-methyl. In that case, there I'm going to have a branch at position 2 or position 3 anyways. You could use either name. In organic chemistry, usually things take priority. So if the halogen group is more important, I might want this number here to be tinier. So if I had put the fluorine over here, maybe I would call this one here 2-fluoro, 3-methyl, but for the time being, it doesn't matter. So let's just say 3-fluoro, again, the same ending there with the 2-methyl there. Could it also be position number 4? Okay. Well, position number 4, it's not 4-fluoro, 2-methyl anymore. I would have counted it 1, 2, 3, 4. This is actually a 1-fluoro, 3-methyl. Now, we haven't put the methyl in position 3 just yet, so that is actually a different isomer. It is possible, just alphabetizing sake here, it could be a 1-fluoro. At position number 1, there's a fluorine group. At position number 3, there's a methyl group. Methyl. And that one there's off of a butane. Still a 4-carbon chain. Okay. Again, that is a different name. That's not a name that we've seen earlier, so that is a different isomer. So that actually has, when I have 4 carbons in a row like this here, that would have been the next thing I checked. Is it possible that I have my alkyl group? We said it had to be somewhere mid-chain. Is it possible that the carbon is off this 3rd carbon? If this was the only carbon here, I would have called it 2-methyl, it would have been the same. But again, because the fluorine can be in multiple different places, the one we just drew earlier here had the fluorine on the end. That looks different from the molecule that we did earlier. So that's the 1-fluoro-3-methyl. Okay. What if I put the fluorine here a little bit inwards? Okay. That's my earlier 2-fluoro-3-methyl. So I have that one there. It could be like that. What looks like 3-methyl and position 3. Okay. Well, that's just 2,2. We had done that one before, 2,2 before. Okay. So again, having the word name here is actually really helpful. It actually gives you a sense, have I gotten that one yet? Or is it now a different one? Okay. Let's just check. Again, it's possible that we can shorten the chain one last time here. What if we have 3 carbons in the chain? Okay. Now I have, let's just draw the extensions here. I can have a fluorine. I have the equivalent of 2 other carbon branches. They could be 2 as methyl. Actually, is it 3? That's 2 methyl branches, or it could be an ethyl branch here. Carbon branches are sort of limited. Okay, so carbon branches, they can't be on either side. So we're going to put a C, maybe a carbon like that. Okay, I know I couldn't be an ethyl because if I tried being an ethyl here, our parent would actually be 4. Okay, so that's why I know it has to be a dimethyl. Okay. But there we go, that's a possibility for the methyl groups. So we may have one other isomer here. I've dealt with the methyl branches here. What if I have a fluoro branch? Well, let's put the fluorine over here. This one here should be the last of it here. If my parent is just going left to right, okay, we can just number this here. F for fluoro comes before the methyl, so we might have 1, fluoro. This time you have 2 of the same identical methyl branch. They're both off position number 2. So 2,2-dimethyl. Don't know why my letters are disappearing here. So 2,2-dimethyl. And this is all off of a 3-carbon chain here, propane. Again, different name, different structure isomers. Okay. Now you might be worried, well, what if I move the fluorine around and whatnot? Turns out if I tried, since this molecule is already so sort of compact here, if I tried moving the fluorine anywhere, this fluorine can't add to the middle because that already has 4 different attachments to it. If I put the fluorine on this side here, then my parent would just switch to this one, okay? And that would also be a 1-fluoro, 2,2-dimethyl. If I put the fluorine trying to be in position number 3, well, back to this parent here, that would actually just be back to position 1 as well, okay? So again, it's a lot of detail, but if you're really systematic about it, start from the longest chain and steadily make it shorter and shorter. You should be able to hit all of them. Even if they don't ask you to write the word name, I generally write the word name anyways. If you happen to have exactly the same name as before, you just drew a slightly different look at that compound there. It's the same isomer. If it has a different name, you can keep it. That's going to be the new structure isomer. On your worksheet, sometimes they're a little bit nicer. They don't ask you, oh, here's a molecule, draw all of them. In the worksheet, they may just say, draw all the isomers that happen to have 2 methyl groups. So they're sort of zooming in. They're sort of saying, okay, what if I took this one here? What if I really thought of these as 2 methyl groups here? Which isomers, not all the variety that we just went through here, but which isomers with 2 methyl groups? Oh, only this isomer here. So they may only be just picking out 1 or 2 of the isomers specifically there. Okay. So if you just wanted one for practice here, just going to leave you with just a formula here. This one, just for practice, I'm going to give you, draw all the structural isomers here. I'll keep it a little bit tinier here, C4H8. Let's put on, let's say, 2 iodine groups here. Those iodine groups here are identical to each other, so you can't tell the difference. But let's see all the possible spots where that iodine can actually show up there. Okay. So let me start you off with the biggest one, and then I'll leave it to you. Okay. So let's do 4 carbons in a row. Okay. I imagine the rest of these are saturated full with hydrogens, doing it really systematically here. Let's start putting the I's here on the chain. Okay. So that's the very first one here. I'd suggest you keep one of them as is, move the other one. And then once you sort of finish moving the other one, move this one once and move it down. I know the names are not going to change by too much, but again, if it's a different name, it's a different structure isomer. All right. So have fun with that one. If you have any questions, just let me know. Thanks, guys.